Mathematicians, nice to see you. Home with the sick kid. So, show must go on. We're checking out a little criterion B practice round. And we'll jump to that in a second, but let's just like remember how to do some math because maybe you were in art class last time, and that's fine too. This is a proportion. That means that like this, if you look at proportions in general, that means like, oh no, not last open version. If you look at proportions in general, things like 1/2 and 4/8, those are the same thing. They just have a little bit of a different look. And so you'll find that if you multiply these together, 1 times 8, you get the same product as that. It's called the cross product property. And we can use that when we don't know things like x. So we can say this 2 sets of x plus 1 should be the same as this 4 sets of 2x plus 3. And then when you do a little distribution, get 2x and 2, little distribution, 8x and 12. And then we got x's on that side, we got x's on that side, so let's crush them all together. So I'm going to subtract 2x's from here, 2x's from here. We're going to subtract 12 from here. So we're basically switching sides with everything. Consolidating everything and putting the x's on one side. So that's 6x, and this is -10. Let's divide by 6, You're left with x is -10/6, and that is -5/3 when you simplify it. And leave it. You don't need to simplify it more than that. That's good. So what I want to practice with you, or have you practice today, is a little mock criterion B assessment. So just like we did with our criterion D, I want to give you some time to play with this. Maybe you have already, maybe you haven't, that's fine. And then we'll come back together and I'll walk you through it. But I do want you to have time to sit, get some big eyes and be like, whoa, what is this? What do they want? I want you to have that experience individually. I know you can chat to your buddy about it, but you're not going to have that opportunity in the real criterion B. So practice like we're going to play, okay? Take the time, 10 minutes, whatever, and try it by yourself just so you can think about what's happening. So if you look in your fancy packet on page 55, it's this criterion B practice investigating patterns, and it looks like this. So this is a little more condensed. I'm going to open it up and show you this in slow form, but you can kind of see what the criterion B looks like. I want you to be able to find patterns and then describe them and then verify them and then justify them, prove them. And I want to walk you through what all those pieces mean. So in all of these, and all the ones that we'll see this year, I'll show you a pattern. And for a 4, all you have to do is kind of like replicate it once and like with words or some way enunciate to me that you can see the pattern and what it is. Pretty straightforward, right? I want this to be like you get into a 4 in like 10 minutes, right? A 4 should be like you're just using normal math to find a pattern, easy. Verify is like you're picking your own variable or your own values and putting them in and seeing if it works, to check that it works. In 6, to hit that 6, you're looking for describing it with variables. In justification, or describing the pattern, and justification, I want to see some sort of proof that it works. So let me walk you through one. Okay, so if you haven't, take the time, take 5-10 minutes and try this on your own, just so you can see how it feels like to be confronted with a new situation. You'll get that little bit of flutter, and then you'll settle down and your mind will start working on it. So there's a lot of things I can see here, but this is what I'm noticing with these. First, like, I'm just going to check that it's right. Like this 4 squared minus 3 squared equals 4 and 3. This is 16. This one's 9. And 4 plus 3 is 7. Oh, hey, this is 7 also. Okay, interesting. So I can tell it works. And I won't give you anything that blatantly doesn't work without cueing you in on it. But I want to think about like why this works. And what you notice is like with this 12 and 11, 12 squared minus 11 squared, we could do that too and figure that out. But I don't really want to find 134 squared and 133 squared. You can use your calculators for these, but like I don't want to have to do that in my head. I'd much rather just be able to add them because I can do that. So I want to see if this pattern works. One thing I do notice about this pattern is that whatever this is one less than that. So describe the pattern you see. Maybe I'd say a number squared subtracted from one more than it. From one more than it squared is the same as those numbers added. 4. Done for the most part, right? You can see what's happening, and maybe you could extend the pattern or just like try another one and see if it works, right? How about 2 squared plus 1 squared? Does that actually equal 2 plus 1? This is 4. Oh, sorry, difference. 2 squared minus 1 squared. That's 4 minus 1. Is that really 3 plus 3? Oh yeah, 3 equals 3. This is a true statement. Okay, so I can see that it kind of works with some real simple ones. If we were trying to be a bit more technical, you know, these words squared is terminology, subtracted from, squared, added, all of that's good. That's interesting. If we were trying to be slightly more technical with this, maybe this is what I would look for. I might say the difference of a number squared, well, maybe the square of a number, of the square of a number and the square of one less than that number equals the sum of the two maybe unsquared numbers. All right, that's fine. So that's good. Let's try to verify your pattern with some examples, new examples. Okay, so you know, I do want to see you try some of these for the 4. So can you try this and see if this actually equals that? We saw that 3 equals 3. Yes, it worked. So there's like example 1. Now that's cool, and we could do 5 and 4, right? And see if 5 and 4 work. Oh, not squared. This is verify. It's like pick some other examples and check. So there's 25 and 16, and we could say, is that really 9? Hey, look, 9. Yeah, okay. And we could just keep picking things that are like kind of boring and easy. But what I want you to do in here, so here, this is like 4 and maybe into the 5s. I want you to also try to pick some things that are not trivially easy. Try this. This one had 130s, right? Try a big number. Does it work for, I don't know, does it work for 20 and 21? Try it. Does it work for Is this really 21 plus 20? Try it. Grab your calculator. I don't want to see you do this in your head. I mean, I'm sure you can, but we don't have time for that. Move on, right? See if that works. Try 207 and then 206. Is that really 207 plus 206? Yeah, right? So those are kind of like medium levels. Add some complications. Try it with decimals. Does it work with decimals? Try it with like, new color. Try it with 3.25 squared. And one less than that is going to be 2.25 squared. Does that really equal 3.25 minus 2.25 plus, sorry. Right? So try it with interesting things. So try it with basic things, slightly more complex. Try it with interesting things. Can you do it with square roots? Can you do it with like square root of 14 squared minus square root of, well, this is good because it leads us to where we're going. 1 less than root 14 is not root 13, right? Think about like root 9 is 3. And if you took root 8, that is not 2. It's not 1 less. So if you really want 1 less than this, you'd have to say root 9 minus 1. Right? This is 1 less than this. So try it with interesting things, and you'll see why, like, maybe that's a good stepping stone for where we're going. So this would be like root 14 minus 1 squared. Cool. Now you're getting into some interesting things. Is that really the same as root 14 plus root 14 minus 1? So you'd have to show that this is 2 root 14s minus 1. You can get some gross decimal for that. This is going to be, I don't know, whatever it is, 5.287, making stuff up. And you could crunch this through your calculator. Maybe if you wanted to show that you understand how this stuff works, you'd show that these canceled out. You'd be subtracting, this is root 14 minus 1 times itself twice. And so this will be root 14. This is just 14, so it'd be minus 14. This is 1, 2 negative root 14s, but the negative distributes in there, plus 2 root 14s. And this 1 and 1 becomes positive, but this negative comes ripping in and becomes negative. You'll notice that these cancel out, and you're left with this exact same side. So it doesn't actually matter what the decimal is. So you don't really need this thing. Yeah? Play with that, right? There you go. That's definitely like into the 5, 6, right? Because you're doing interesting things. So here, it matters here what you're doing, like which examples you pick. And I'm not gonna tell you, pick interesting things. Pick the things that you're like, ooh, I don't want to do that, because they add interest, right? Decimals. Okay, maybe it works, maybe it doesn't work. Some things don't work with, they only work with whole numbers. Same thing with this. We've been dealing with radicals. Throw that in there and see. Try some fractions. Show me that you can do fractions with this. See if it works with like 5/3 squared minus 1 less than 5/3 is 2/3. If that freaks you out, we got to talk. Does that really equal 5/3 plus 2/3? I don't know. This is 7/3. This is 25/9 minus 4/9. Oh, I see what's happening. That's 21/9. Oh, nope, not the same. Oh, wait, this thing simplifies to 7/3. Oh, and that's equal to 7/3. Yeah, it works, right? So try some interesting things, not just like the boring stuff. Okay, now comes, so that's into a 6. Yeah, especially with this locks it in as a 6. So just add interest. Show me that you can work with radicals and fractions and things that aren't just like nice numbers. Yeah. Now let's get to the justify. justify, prove, whatever. I want to, like, maybe we just got lucky picking this one and this one and this one and this one and this one. Maybe I just got lucky picking the ones that worked. I want to show that this works for any of them. So we got to think in the variable terms. So I'm going to pop to here. We have to sort of generalize this idea, change this into variables. So a number, let's call it, I don't know, x, n, whatever. So we're saying the difference of the square of a number. Oh, the square of a number. Oh, the difference of a square of a number and the square of one less than that. Well, what's one less than x? Well, it's x minus 1. If this is 3, this is 3 minus 1. If this is 14, this is 14 minus 1. And square them. And that should be equal to the sum of the the unsquared numbers, x and x minus 1. Okay, so let's take that and run. So we said, I've got a number, I square it, I subtract it from that number and one less than it squared, and that should be that number and the one less than it added together. Can we make that work? Can we add those together? Let's try. This side I know is x minus 1 times itself. That's what the squared means. This can open up because we don't really need the brackets anymore. So here's your x squared minus x squared, negative 2x's, and 1. And this side is 2x's minus 1. This little cheeky negative distributes in here because you're subtracting all of those pieces, those components. So you're going minus x squared plus 2x minus 1. Those are out of there, subtract, and you're left with 2x minus 1 equals 2x minus 1. I think you could probably leave it, but if you really wanted to be awesome, you'd say, all right, well, minus 2x minus 2x. Negative 1 is equal to negative 1. Undoubtedly, yeah? If I'm in debt one franc to you and you're in debt 1 franc to me, we're even, yeah? So we've taken our setup. This is the hardest thing to do in 7 and 8, is generate this equation. Said a number minus 1 less than that number. Oh, it's the squares of those numbers. That's going to be equal to those two numbers, the number and 1 less than it added up. That's the hard part. And then play around with it until you get a true statement. A true statement might look like 0 equals 0. That's true. You give me 0 francs, I'll give you 0 francs, we're even. Yeah? Or it could look like, 50 equals 50. As long as it's a true statement. If you get a false statement, which sometimes happens, it tells you that whatever you're thinking doesn't work, is like 2 equals 50. This says no way. But note, we're not solving for x. It's not like at the end I get x equals 3, because here it's all variables. I'm not solving for x. I just want to see if this is a truthful statement or not. Is this true for any variable? So in the end, I want my variables to go away and only be left with truth. It's kind of cool. Okay, so there's a CritB to play with. There's a couple others. There's 2 others on Schoology. If you go into Schoology, one of them looks like this. A little more basic, but the same idea. 5 is greater than 2. Remember the alligator mouth discussion? Same sort of thing. Negative 3 is less than 4. Those are true. Okay, fine. And so we're going to mess with them by adding or subtracting or multiplying, dividing to both sides and see what happens. You're going to see if that works, if there's other examples that make it true. And then you're going to see if you can justify it with variables. So also in there is sort of a worked solution that you can read through sideways. Yeah, that's better. About how I might go about dealing with that. And then also the justify. So there's one for you. And The other one with irrational lengths is here. Ooh. Keeps trying to make it big. Now this is a similar idea where you're looking at square roots to make different lengths and trying to draw some conclusions from the Pythagorean theorem. So you can also mess with that one. Kind of guides you through, so explain some patterns that you see. Can you actually make root 11? Can you make root 12? I know I can make root 16. Probably 4 and a 4. No, not a 4 and a 4. That would be, yeah. So can you make these as you like, just with actual lengths? Can you mess around with like a squared plus b squared and actually get root 12 to be the c squared? Maybe, maybe not. Here's all of them from 1 to 100. Which ones can we actually make? Like diagonals that are actually this length or that length. Can you actually make those on the grid? And there's some patterns that show up there. Cool. So some of them can be made in 2 different ways. How do you make those? Think of just like symmetry and triangles and such. Cool. So there's a more of an unguided one if you want to practice that skill of not knowing exactly what to do and playing, because I want you to be able to get into a 4 relatively quickly and then have lots of time to play afterwards. Cool. I hope that helps. I'll see you